going to take a look at two examples using the rectangle approximations, which is also called a Riemann sum. You'll see that word being used also. Okay, so now we're giving this the numbers in a table format. So this is the rate at which water is being pumped into a tank. The function is continuous and increasing, and the function is called R of t from 0 to 13 minutes. So this is saying that at time 0 in the beginning, water is being pumped into a tank at a rate of 7 gallons per minute. And then 4 minutes later, the water is pumping quicker, right, at 13 gallons per minute, etc. So it says using a right-hand Riemann sum. So you'll see that sometimes, and basically that's just using your rectangle approximation. So we're going to go ahead and use a right-hand rectangle. We're going to use 4 rectangles to approximate this area underneath the curve. So when I give you a table, you have to use the numbers in the table. You can't come up with any numbers that are not given. So this is my first rectangle. It goes from 0 to 4. So this is like your x value, your time. So the width of the first rectangle is going to be 4. And then this is going to be the height or the y value of the rectangle. So which number's on the right side? It's the 13. So there's your first rectangle. Your second rectangle goes from here to here. Width is 2, and then I'm hitting on the right side, so the right number, y value, would be 18. And so the pattern continues. The next one would be 4. Then right hand would be 23. And the last one would be 3. Right hand value would be 27. And if you punch this all out, you get 261. Okay, now let's think about, okay, what does this 261 represent? Okay, let's do units here. What's the units on the 4 that we came up with? The units on the 4 was minutes, and the units on this 13 is gallons per minute. So notice what happens. So all of these rectangles, your units are gallons, so this is really 261 gallons. So this number is saying from 0 to 13 minutes, 261 gallons, and what is this talking about? Of water has been pumped into the tank. That's what that number represents, into the tank. Okay, and then here's that same question we saw before with the graphs. Is the approximation greater or less than? Well, the only thing I know about the function that is r is increasing. So if this is an increasing function, if I use a right-hand rectangle, what do we notice happen? It always goes over. So we're going to say it's greater. And then your justification is because they told us that r of t is increasing, right? Always justify with what's given. Okay. Now let's talk about a midpoint. And a midpoint for a table is going to be slightly different than when we did it with the graph. And the reason is you're not actually going to use the same number of rectangles. Okay, again, with the table, you have to use the numbers in the table. So you can't make your first rectangle go from 0 to 4 and then pick a number in the middle and just make up a number because you don't know what that number is. So in order to do a midpoint rectangle, I need a number in the middle. So your rectangle has to go all the way from 0 to 6. So the width of your first rectangle would actually be 6. And then what's that y value in the middle? It would be 13. And then your second rectangle would go from here to here. The width would be 7, and then the middle y value there is 23. So notice when you do a midpoint, you actually have less rectangles than we did for right or left, and only when we do it with the table. And this one ends up being 239. So I mean, these values should be somewhat similar to each other. Okay. Let's get one last problem. This is the rate at which customers are being served at Starburst. Again, it's a continuous function from 0 to 10 hours. At t equals 0, there were already 200 customers being served. So basically 200 customers have already been served, and right when it starts, there are 37 people per hour being served. That's that rate. Okay, so this time we're going to use a trapezoidal sum. So the only thing you need to know is the formula for the area of a trapezoid. 1/2 times the height times the sum of the two bases. So remember, it's just like a rectangle. So there's my first trapezoid. So what's the height? The height is really that width, which is 2. And then your bases are your two y values. So 37 plus 44. Go to your next trapezoid. 1/2, height is 1, and then 44 plus 36. Go to your next one. 1/2, 3, 36 plus 42. And the last trapezoid is 4, 42 plus 48. And if you do all the arithmetic here, you will get 418. And the units on this should be 418 people, right? Because this is hours, people per hour, and the hours will drop out. Okay, here's the last question. Approximately how many customers have been served after 10 hours? So you have to be very careful about what they're asking you. Notice in the previous problem, I said from this time interval, 0 to 13 minutes, 261 gallons were pumped. So this 418 people is in this time interval from 0 to 10. But this problem said there were 200 customers to start with. So if they asked you how many people were served from 0 to 10 hours, then this would be the answer. But because they're asking you how many people were served after 10 hours, you have to account for that 200 people that were there to start with. So the answer to this one would be 618 people.